Welcome to this video tutorial. This video shows the construction of a full upper and lower denture with the BDCreator PLUS. The data of the situation shown was created and exported with the DScan 4 scanner. First, a project must be created in BD Manager 360 degrees and the project task defined. A new project is opened by clicking on the plus symbol. A customer name or a customer number can be entered. Transfer an order number and assign the name of the project. You can also store comments in the field for notes. Only when the three upper fields have been provided with information does the switch for Apply become active. A title for the project then appears in the project overview. This can be called up again at any time. A tooth scheme appears. To select the appropriate jaw, click on any tooth in the jaw. A black menu bar appears in the upper work area. A click on the Apply Work Type symbol leads to the selection for defining the project. In the work type group there is only the option Full Denture. In order to be able to create a full denture for the jaw, BDS must now be selected. The fields marked with a red asterisk must be filled out under Options and Parameters. This concerns the information under Functional Impression, to indicate whether a model or an impression is available for the construction. Click once when using scan data from a model. When you have impression scans, click twice. The second important information is the information about the color. This information is linked to the color of the BD load, pink or dark pink. A BD key should only be selected if one has actually been used. A pre-selection of the tooth selection is not necessary but can be done if you want to determine the setup to be used. It is not necessary to set the advanced parameters. The default settings should only be changed in consultation with support. By clicking on Next, the selection jumps back to the tooth scheme, and the selection for the lower jaw can be made accordingly. In the tooth scheme, the areas around the teeth appear pink. The creation of a project is complete. The construction software starts by clicking on the design symbol. After starting the software, a message appears stating that no scan data is available yet. In the case shown here, the data are selected individually from the export folder of the scanning software and imported. In the scanning process, the data were not yet aligned with each other, so they are in a disordered manner. Before the scans can be registered to each other, the settings on the right work page must be checked. The button for the presence of a model scan must be active in the case shown. The button model or impression should be activated according to the situation. In the present case, model must be active. For the design of total upper and lower jaw prostheses, the No Antagonist option must be selected in the Antagonist Setup selection menu. The registration state refers to whether the situation is already aligned with one another or whether this still needs to be carried out in the software. If the check mark is set, the software skips the registration step. Since no BD key was used for the impression, no selection needs to be made here. The next step is to register the data with one another. A note from the software at the bottom of the work area indicates the need for alignment. In a selection bar below the menu field, you can switch from the overview to the alignment view of the upper and lower jaw. In the alignment view, two objects appear on the screen at the same time. By holding right-click on an object, it can be rotated with the appropriate mouse movements. The object can be moved by clicking and holding both cursor keys. Clicking and holding the mouse wheel causes the object to be enlarged or reduced. The objects should be aligned roughly the same. In this way, distinctive points can be selected that match in both representations. By clicking on the Pre-Align button, the objects will be aligned with one another. The result is usually not yet perfect. By clicking on the Fine Align button, the data are aligned with one another again. The result should be improved afterwards. A spotty penetration of both objects indicates a good match. The alignment of the opposing jaw must be selected and can be done in the same way. To complete the work step, the selection bar must be switched to Overview. In this selection, the result can be checked. Only in this selection is a click on Next possible. In this step, the wizard on the right guides you through the required actions. The creation of the points results in an alignment plane, comparable to the used plane, when mounting the models in the articulator. A view of the resulting horizontal plane is displayed in the lower left corner of the work area. This preview can be enlarged and moved by clicking on the object with the mouse wheel, turning the wheel and moving the mouse. In the following step, the position of the plane can be checked and corrected. For a better overview, the vestibular scan can be hidden with the View function. One of the most important functions in this step is the ability opening of byte. The slider can be used for this, or the desired value for the increase or decrease can be entered directly in the field. A value for lowering must then be preceded by a minus sign. The plane can be moved in all spatial levels and axes by using the functions on the right area of the workspace. The icons in the lower display bar can be used to switch the view quickly. A rotation over 45 degrees automatically hides the opposing jaw. Markings for the posterior region, the anterior region, and the anatomical center are created on the transparent alignment plane. These support you in correcting the alignment of the jaw. The frontal marking should be aligned with the anterior border of the alveolar process. The changes are accepted with the Apply button. A model analysis supports the software in the automatic selection and alignment of an initial proposal. In addition, the user can check the selection and positioning of the row of teeth according to static aspects. The software suggests the markings for a model analysis on the jaws. These must be checked by the user. A wizard on the right-hand side of the work area describes the individual steps. The arrow keys on the figure below guide you through the individual steps. Corresponding instructions are contained in short texts. The zone for defining the retromolar areas in the lower jaw and the upper maxillary cusps, tubera maxilli, can be moved by clicking and holding on the orange point. The zone edges move with the point. The software automatically places the orange-colored point in the center of the zone. If the border line is touched with the cursor, it changes from black to yellow. Click and hold on one of the points with the left cursor key. In this state, the points can be moved. A single left click on the line adds a new point. Right-clicking on a point removes it. This also applies to all lines and points in the following steps. After working on the retromolar areas, the positioning of the tongue ligament must be checked. The location is marked with a green dot. Next, the position of the cheek frenulum is checked. The position of the first lower premolars is roughly in line with the cheek frenulum on the alveolar ridge. The center of the alveolar ridge is to be defined at the highest point of the ridge, between the lingual and the labial frenulum. To determine the lowest point of the alveolar ridge in the posterior region, the alveolar ridge must be viewed from the side. The stop line. From this point on, there should be no tooth contact in order to avoid shear forces in the direction of the masticatory center. The anatomical limitation for setting up a second molar is determined by the anterior point of the trigonum retromolar. No tooth may be positioned beyond this position. This counteracts any sliding of the denture. In the subsequent work step for selecting the teeth master, depending on the space available between the position of the first molar and the stop line, a setup with or without a second molar can be selected. The model analysis for the upper jaw starts with checking the marked position around the papilla incisiva and checking the marks for the upper jaw cusps. The position of the canines is marked as an extension of the first large pair of palatal folds on the alveolar process. The position of the first upper premolars can be determined approximately 3.5 to 4 mm behind the position of the canines. This position, in connection with the midpoint of the tuber maxillae, defines the basic static line for each jaw side. The lines will be automatically suggested by the software in the next step. The green dots are used to mark the position of the pharyngeal folds, as well as the lip and cheek frenulum. In the literature, the labial stop surface, yellow, is defined as average at a distance of 8 mm from the center of the papilla incisiva. The surface is at a 90 degrees angle to the alignment plane. The labial surfaces of the first upper incisors should be adjacent to this position, unless otherwise specified. The distance of 8 mm is automatically determined by the software and indicated by a yellow area marking. The display of the vestibular scan helps to check the information from a bite registration. By moving the green arrow, the position of the level can be adjusted. The upper and lower row of teeth must be functionally aligned to each other. One of the general rules for the teeth setup is that the lower jaw teeth must be placed in the neutral corridor. That means not too far in buccal or oral direction to prevent that the patient neither bites into the cheek nor into the tongue. Also, the chewing forces must be absorbed over the teeth onto the foundation of the denture. According to this requirements, the upper and lower posterior teeth must find a statically stable support on their bony foundation. The canine-guided occlusal concept in combination with a lingualized occlusion, in the relationship of the posterior teeth, is still implemented in the BD load. For defining the setup corridors, it is recommended to select Gerber. This option offers the greatest leeway for the upper jaw teeth placement and fits perfect to the setup concept. The blue area should run along the outside of the alveolar process. It can be corrected for alignment and limits the contact zone for the working cusps of the upper posterior teeth. Cusp contact, outside the blue area, must be avoided to ensure the position stability of the denture. The displayed yellow fields illustrate the zone for the positioning of the working cusps of the upper posterior teeth. These fields are used for clarification in this video and are not generated or displayed by the software. If a balanced occlusion concept is desired, you can continue with the definition of the corridors by selecting TIF. The implementation of a balanced occlusion concept is explained in a separate video. The next step defines the direction in which the denture base will be inserted. The arrow is initially set at an angle of 90 degrees to the alignment plane. This alignment must be corrected into the direction in which the denture will be inserted by the patient. To change the orientation, either the arrow or the model can be moved. By slightly tilting the model to the alignment plane, the direction of insertion will change accordingly. A click on the left button changes the orientation. The undercut areas resulting from the direction of insertion in relation to the specified and displayed parameters. These areas can lead to pain when inserting the denture or even prevent insertion in extreme situations. Since the mucosa is resilient, some parameters can be changed in order to allow undercuts within a defined frame. Changes to the parameters in the right toolbar affect the undercuts. In this way, an additional angle to the viewing plane can be chosen, and a defined undercut depth can be allowed. The respective changes to the parameters are shown on the display in real time. A surface correction of 0.03 mm is preset. This correction evens out the surface and has, due to the resilience of the mucosa, no effect on the fit of the denture. With this correction, the finest depressions and unevenness will be smoothed. This avoids sharp edges on the underside of the milled denture base. If desired, this correction can also be suspended by setting the value to 0. A correction is always recommended. The undercuts in the lower jaw will be checked in the next step. The borderline for the base must be determined in its extent. A border is automatically suggested from the software and can be edited. The base should run according the lowest point of the vestibular fold. The denture base should encompass the areas of the tuberosity in the upper jaw. This significantly influences the positional stability of the denture. It is possible to virtually erase the dorsal damming of a denture. At the deepest points of the arcus glossopalatinus, on the right and left of the maxillary palatal suture, the etching is carried out with the set value as a maximum, since this area has the greatest storage possibility in the mucosa. From there, the etching is applied to the anterior border, becoming flatter and flatter. The etching is interrupted at the palate suture, as this area is hardly flexible. A cover to relieve the papilla incisiva and the torus palatinum is possible. In addition, other areas can be edited for relief. These possibilities can be used optionally. The base is then calculated. The minimum thickness of 2 mm is specified and cannot be fallen below. If a stronger base is desired, the strength can be increased accordingly. The basic edging of the lower jaw follows the same principles as for the upper jaw. The base should run according the lowest point of the vestibular fold. The denture base should encompass the trigons in the lower jaw. The software displays a mathematically calculated initial proposal between the two jaws. This is oriented and aligned to the occlusal plane. A fade-in of the vestibular scan can be helpful for adjusting the position of the row of teeth. The information from a vestibular scan can also be adopted in this way. From the selection menu on the right-hand side, all other rows of teeth can be chosen. According to a mathematical consideration of the software, green setups can be used well. The yellow ones can be used with corrections in the position. The software does not recommend to use red rows, but in principle the user can choose any row of teeth. The pre-selection by color is only an assistance for a selection to find a good match quick and easy. In the situation shown, a red row of teeth was deliberately chosen. The setup and the base are shown in red. A closer look reveals the cause. The selected row of teeth collides with the base in the present alignment, which leads to penetrations that make further calculation problematic. A red coloration of the row of teeth can also be caused by a collision with the boundary lines from the model analysis. The software interacts with the information previously generated and helps the user to make the right selection. By moving the row of teeth with the alignment tools, collisions can be resolved. The red coloring disappears and turns into a green color. The user can verify the changes to the specifications from the vestibular scan. In the result, the setup for the teeth row named MM7 fits into the situation. Just for an example, the LN6 setup is selected from the menu. To explain the designation, L stands for large, with correspondingly large teeth. N stands for a narrow arch shape and 6 stands for the number of teeth per half of the jaw. For the large setups, L, only setups with 1 molar are available. The setups for the medium size, M, and the small sizes, S, are also available as setups with 2 molars, signed with a 7 in the nomenclature. The information from the model analysis can be displayed by using the show and hide functions. The user can thus assess the positioning of the teeth inside the defined field from the model analysis to verify the correct position of the posterior teeth. The positioning of the lower row of teeth should also be assessed. The posterior teeth should follow with the central fissure the highest crest of the alveolar ridge. Different variants of the constellations can be tried out and assessed in the results. The software connects the selected and aligned row of teeth with the denture base and generates the dentures. As an option, a copy of the palate mucosa can be transferred to the palatal surface of the denture. The transfer area is suggested and can be edited. It is recommended to keep a distance between the palatal surfaces of the anterior teeth and the palatal folds. Otherwise, they may penetrate the transition area between the tooth and the denture base and affects a negative result. The milling blank of the corresponding jaw should be displayed to check whether the construction fits into the BD load. The freeform tools can be used to make changes to the surface of the denture. Material can be applied and removed virtually and smoothed. The strength and radius of the effect can be adjusted using sliders. When applying material, it should be noted that the BD load only allows a limited amount of material to be applied. The edited areas appear colored red and thus show the changed areas. Click on Optimize Surface to apply the changes to the construction. In the final step, the entire result, or just the individual jaws, can be viewed. The view can be changed using the selection bar in the upper work area. The middle button in the right work area helps to call up the various work steps directly. This could be necessary in order to view or change individual work steps. Careful! If changes are made in one step, a warning about the change in the data situation appears. If this is confirmed, all of the following steps must be repeated. Therefore, a change must be carefully considered. On the right-hand side of the work area, you can select an output of the data from various options. This enables the further processing of the data in different softwares. If the present case is to be milled, it is possible to output the data directly prepared for a corresponding CAM software. In the present case, an optimization for a CAM software is selected, and by clicking the button in export mode, the data will be generated and saved in the project folder. The project can be closed with a click on Finish. Thank you for watching this video. See more videos and find detailed informations on the Baltic Denture System website.